Right now, 3I Atlas, the third ever confirmed interstellar object, is racing through the inner solar system. Its path takes it inside Mars's orbit, accelerating toward a close encounter with the Sun at nearly 68 kilometers per second. As global telescopes prepare for the mid-October solar conjunction, this alien visitor will plunge into the Sun's powerful electric field, slipping beyond the reach of human sight. Scientists are left with only speculation, trying to make sense of its unusual chemistry, enormous scale, and unpredictable behavior. Imagine a 50-kilometer chunk of another star system colliding with the solar wind at unimaginable speed, unseen and untouchable by Earth's eyes. If you love deep dive space mysteries, like this video to help it reach more sky watchers. Its trajectory is unlike anything in the solar system. 3I Atlas moves 5 degrees off the ecliptic, its orbit steep and retrograde, slicing nearly head-on through the plane of the planets. With an orbital inclination of 175 degrees, it is a true outsider, crossing the planetary highway in the opposite direction of every asteroid and comet that orbits the Sun. Its journey is relentless. Discovered in early July by the Atlas survey, it was already traveling at 58 kilometers per second. Now, approaching perihelion, that speed climbs steadily to nearly 68 kilometers per second, a velocity that would carry it from Earth to the Moon in just over an hour. What's your bet? Volatile comet or something we've never seen before? Comment your theory below. Perihelion will occur on October 29, 2025 at 11:55 UTC inside Mars's orbit, yet still far from Earth. Unlike classic sun grazers, Atlas will not dive into the corona, but thread through the turbulent region where solar wind and electromagnetic fields reach peak intensity. From Earth, its closest approach occurs in the constellation Virgo, yet solar glare renders it invisible. Its hyperbolic orbit guarantees a one-time visit, a fleeting brush with the Sun before it continues into the void, never to return. For astronomers, the countdown to October 21, 2025 marks the beginning of enforced silence. Superior conjunction occurs when Atlas slips behind the Sun, hidden from ground-based and most space observatories. For weeks, the Sun's blinding glare blocks visible, infrared, and ultraviolet signals. Despite months of urgent coordination, 120 observing campaigns, emergency overrides at flagship telescopes, and late-night global calls, all direct observations are paused. By October 18th, the comet's apparent separation from the Sun drops below critical thresholds, making ground and space detection nearly impossible. Coronagraphs like SOHO and Stereo offer little hope. At magnitude 12, Atlas is too faint, too compact to stand out against the turbulent solar corona. Mars orbiters captured a fleeting glimpse in early October, but even these low-resolution spectra and long exposures were barely enough to detect a faint coma. Attempts to redirect instruments for perihelion imaging were hampered by resource limitations, orbital constraints, and instrument safety, leaving a crucial observational gap. The recovery window opens in mid-November as Atlas emerges from behind the Sun into the dawn sky. By this time, it will be receding, dimmer yet still accessible to large telescopes and dedicated amateur observers. The next milestone, December 19, 2025, its closest approach to Earth at 180 astronomical units, just before the winter solstice. Between conjunction and reacquisition, every moment is filled with anticipation. Each lost hour to solar glare is an hour when this most anomalous interstellar object could transform, fragment, or fade unseen. Don't miss the post-conjunction updates. Subscribe for the follow-up episode when new data drops. 3I Atlas is large but uncertain in scale. Estimates place the nucleus somewhere between 5 and 50 kilometers across. A dense, unresolved coma hides the core, so size and mass are inferred indirectly from brightness, scattering behavior, and the expansion rate of the coma, rather than from direct imaging. Its behavior is unusual. The coma's color shifted from early red tones to a striking green by August, consistent with a CO2-driven chemistry that releases C2 and CN radicals, unlike the water-dominated activity of typical comets. Spectra report nickel ions far out of proportion to iron, hinting at exotic origins, perhaps material processed in a supernova remnant or a stripped planetary core. Polarimetry shows extreme negative polarization, pointing to very fine, possibly glassy or metallic dust rather than ordinary silicates. Morphology deepens the puzzle. The coma is brightest sunward with strong forward scattering instead of a classic anti-solar tail. Its light curve brightened heading into conjunction, sparking debates, active jets versus a reflective metallic sheath, and raising the possibility of fragmentation, volatile outbursts, or newly exposed surface layers. Despite technological sophistication, detecting Atlas at perihelion is nearly impossible. Ground telescopes struggle against solar glare. Space coronagraphs are tuned for much brighter objects. Even stacking hundreds of frames fails to yield a secure detection. Automatic safety protocols prevent excessive exposure near the sun, and no manual override can justify risking sensitive detectors. Mars orbiters offered only a brief window of observation. At perihelion, no instrument remained in position to witness the peak of solar heating. The data gap is absolute. Creative strategies remain: archival data mining, stacking along predicted paths, and hope for post-conjunction surprises. Engineers are already planning for future interstellar visitors, more flexible safety protocols, dedicated stacking pipelines, and even solar observatories designed to track faint comets. For now, Atlas races unseen. If you're following along with a telescope or imaging rig, comment your setup and location so we can feature community captures in the next video. Some researchers advocate electromagnetic explanations. In the electric universe view, comets are dynamic participants in the solar plasma environment. Perihelion may serve as a natural laboratory where solar wind, electric fields, and charged dust interact. If Atlas's CO2-rich dust carries electric charge, solar fields could accelerate particles, reshape the coma, or slightly alter trajectory. Subtle deviations that post-perihelion tracking could reveal. These are testable predictions, not assumptions. Astrologers see a rare setup. Atlas at perihelion in Virgo, opposing Chiron, with a Jupiter-Pluto axis forming a grand cross kite pattern, symbols of transformation and renewal. Its nearest approach near the winter solstice links darkness to returning light, and a March brush with Jupiter is read as new beginnings, purely symbolic but evocative. The story of Three-Eye Atlas is far from complete. What drives its anomalous behavior? Will perihelion trigger further activity or alter its path? Answers await its reappearance in mid to late November. Every new measurement, brightness, coma structure, position, will test our understanding of interstellar objects and push the boundaries of solar system science. For now, only the archival record remains, a reminder of how much remains hidden, even as evidence continues to grow. The interstellar wanderer moves on, silent but unforgotten, a fleeting messenger from another star system, racing at nearly 68 kilometers per second, shrouded in mystery, and leaving humanity to watch, wait, and wonder. Enjoyed this cosmic deep dive? Like, subscribe, and comment your questions so we can tackle them in the next episode.